Hey, today's Wednesday, May 13th. We're going to calculate kinetic energy using a formula, and we're going to see why when we change either the mass or the velocity, the kinetic energy changes. So when was the last time you went bowling? Do you like using the lighter balls or the heavier balls? Personally, for me, I like the 11, 12-pound balls. It's light enough for me to bowl it easily and I can get pretty good speed, but it's still heavy enough to have a lot of mass when it hits the bowling pins. Now, if I were that guy, if you have a big ball like that, it seems like bowling becomes a lot easier. So once again, kinetic energy is the energy associated with motion. So when something's moving, it has a lot of kinetic energy. The more mass it has, the more energy it's going to have, and the more speed it has, the more energy it's going to have, and this is squared. So the speed has a much bigger impact on the total kinetic energy. And so here's some more examples. We have a huge truck that is going really fast, has a lot of mass, so therefore all that energy is able to get transferred to the other cars and move them away. If you're a sumo wrestler, having a lot of mass is very helpful. Being very fast is very helpful. And I think we all would love to try this one time, yeah? You go together, but the person with the more mass and more velocity will have more energy and therefore will bounce the other person off much faster. So on page 90, there's an activity to use a calculator, and you're going to calculate the different kinetic energy values for different objects. So on page 90, we have 4 objects here. We have a bowling ball, a bullet, a ping pong ball, and a softball. Let's try the bowling ball first. So we have 5 kilograms, and the velocity is 6 meters per second, and we want to find the kinetic energy for that. So we're going to open up the calculator, and we had 5 kilograms and 6 meters per second. Let's calculate, and using that calculator it has 90 joules. So we can go back here and fill in 90 joules. So is that a lot? Is that a little? Well, let's find out. Here's a bullet. A bullet is very light, so it only has 0.04 kilograms, but it's very fast, 500 meters per second. So do you think the bullet's going to have more or less kinetic energy than a bowling ball? Let's find out. 0.04, 500, and a lot. It has 5,000 joules. So even though the mass is so low, because the velocity is so high, it has a lot more energy, which is why a bullet is much more lethal than a bowling ball. We'll do one more here. We have a ping pong ball, which is really light, 0.002 kilograms, and kind of fast, 25 meters per second. So let's put that in. Yikes, it doesn't have very much energy at all, 0.625 joules. 0.625 joules. Okay, so I want you to try to see if you can figure out the kinetic energy of a softball. After you do all 4, I want you to answer this question. Out of the 4 objects, which object had the most kinetic energy? Does that make sense? So I'll finish off with a quick song about the kinetic energy formula. See you tomorrow.
It's so kinetic to calculate it. It's 1/2 times the mass times velocity squared. There are many types of energy in motion: light motion, radiant, thermal, and sound. Now here's an example: a car and bicycle are traveling at the exact same speed. Now which has exceeded kinetic energy? The car, because it has the most mass. Objects moving, it's kinetic energy. You can transfer one object to another.